So, good day everyone. We are going to have our hands-on activity in basic assembly language, software, and simulation. So, before we begin our programming, we need to install the following requirements for us to start our program. So, we need an integrated development environment, which is the MPLAB, and its corresponding compilers. So, I have already installed the following requirements, and I just need to open it and execute it. So open it and then grant administrator access once it asks for it. So wait for it to load. So click yes. Then the logo will appear. Then click next. Then accept the agreement. Then here you will choose your installation directory. So I have chosen the drive C to be my installation directory. So setup is now ready to begin by clicking next, and then just wait for it to unpack and install the following files on your directory. So having it installed in the background. So the MPLAB X IDE is a software program that runs on a PC. So whether it's Windows, Mac OS, or Linux. So these operating systems are compatible with MPLAB X IDE. So it is used to develop applications for microchip microcontrollers and digital signal controllers. So all microcontrollers and digital signal controllers use the MPLAB X IDE for programming purposes. So it is called an integrated development environment because it provides a single integrated environment to develop code for embedded microcontrollers. So the IDE provides the environment for you to code. You just need to install the program and then develop your program, compile your files, and then install the necessary compilers. So let's check the. You need to choose install compiler, and then click next, and then click next. Just like your IDE, the same installation directories for the drive C program files. So do not modify anything. Just click next, and then wait for this program to install the files to your computer. So after installing, you will see that the MPLAB IDE already has your shortcut in the desktop. So for your ease, you can just click this, or you can just search the MPLAB X IDE. So, and then click OK. So for our program to run smoothly, we should wait for the program to install first, so that everything is ready, the compiler and the tool chains needed. So to prevent issues. So we need to wait for this to install. So for our hands-on activity, we will be needing 3 compilers: the XC8 compiler, the XC16 compiler, and then the XC32 compiler. So for these compilers, there are corresponding versions needed and the date of when it was released. So the XC8 compiler is version 1.30, the XC16 compiler version 1.21, and then the MPLAB XC32 compiler is version 1.31. So these compilers are very necessary for you to be able to compile programs for different kinds of microcontroller developed by Microchip. So let us check our installation. So it's already creating shortcuts for the uninstall files. Then as per the you will just click OK, and then wait for the program to close with itself. Then if you want to use free MPLAB XC8 compiler, click next. So you will see your host ID here, and then click finish. So good day again. So after installing the program, you will just repeat the following steps with your XC16 and then XC32 compilers. So it's just the same steps. You're just going to follow the previous steps. So open the IDE or the Integrated Development Environment. So after opening, you will see the welcome menu, and then you will need to create a new project. So creating a new project, you will be needing the microchip embedded category, and under it, you will see the standalone project. So click it, next, and then the family where the microcontroller or controller that we are going to use is under the mid-range 8-bit MCUs. So the device is PIC16F877E. So click enter, then next. So under the tool, you will choose the simulator. So if you have your own PIC kit, you can also choose those. So for now, we are going to use the simulator tool. Then next, and under the compiler tool chains, you will be selecting the MPASM. Then next, then you will name your project. So for this project, I will name it Program 01. You can also define your project location and then the project folder. So set it as the main project. Then click Finish. So you will be seeing the different types of files, header files, important files, linker files, and the source files. So under the source files, you will right click, select new, and then click empty file. So a pop-up will appear, and then you will name it as main.asm. So this is our main assembly program, and then we will leave this blank. So that will set the main assembly program to default directory. So we will click Finish. So let me check. Okay, working. So here in your program proper, so this is your workspace. You can type comments for you to be able to discern what your code is all about. So you can also include your name, Macdarrell, and then your activity. So we will be adding value to the working register. Then close it with the asterisk. So anything after the semicolon will not be considered by the microcontroller. So for the first part of our program, we will be typing the comment about it. So use the org directive. So this directive will force the program to start at the reset vector. So putting it into the program, we need to type org. So you should see that the colors of the text differs depending on the type of the syntax you're typing. So org 00, and then so that is just the only thing you need to force the program to start at the reset vector. So the main program starts here. So So you can first task the microcontroller to clear W. So this will clear the values, clear the working register. So it will reset the value in the working register. And then next is to add LW, then 08. This will add 8 to the working register. So here, when you add 8 to the working register, you should also label it here as loop. So align your codes. So this add LW08 is under the label loop. And then for the last part, we will instruct the microcontroller to go to the loop again so that it will reiterate. So it will jump back to the loop. And then we're going to end the program by typing the word end. So after that, you will debug your program by clicking here at the arrow and then debug main project. So you can see here at the bottom part of the screen that our build is successful, and in the simulator and debugger console, the program is also already running. So for us to see what are the values, we need to go here at the window and then click here at the peak memory views and then the SFRs or special function registers. So when we pause the program, we can see that our W register already accumulates 8 value, and then in the whole program, the program pause at go to loop. So we can also use this to step over the program or click F8. So first, when you step over the program, it will jump back to the loop because it is the statement here to go to the loop. So after clicking step over, it will jump back here. So the green highlighter shows where you are now this time, currently this time. So we are at the label loop and we are going to add 08 to the W register. So after jumping here, you can see that the W register is now at 16. And then you can also take note of this, that the PCL status or the program counter low byte changes. So it is now at the address 2. And then when you step over again, it will now go here and then the PCL status will change to 1. Okay, so let us see naman kung what will happen if the W register continues to approach 255. So we need to click here, step over. So I will just focus it here at the lower part for you to see that our working register accumulates. So 40, then loop, add LW08, then go to loop, and then add again 56, 64, 72, 80, 88, 96, 104, 120. You can also press F8 if you're using your keyboard. So 200, 208, 224. So 240. Let's slow down a bit for you to see what will happen to the working register once it accumulates to 255. So F8, 248, and then it will uh, 0. So you can see here that the W register resets to 0. So you can also examine the program memory. So here at the program memory, and then the disassembly, by clicking here at the window, debugging and disassembly, you can see the following addresses that are used in this program. So the address 0 belongs to the clear W. So the address 1 belongs to the add LW and then 0x8. So 0x8 is the hexadecimal value for 8. So then 0x2 belongs to the go to loop. So the go to loop line. So we all know that the loop value is the 0x1. So it will go to 0x1. So you can also see here at the program memory that the 0103 is the opcode. So the 01 refers to the clear, and then the 03 is the opcode. Then 3E08, so the 3E here is the address, then the 8 is 3E is the add LW, and then 08 is the 0x8. And then so go to is assigned to the 28, and then 01 is this one. So you can also see here that when you step over, the PCL status is where your program is located. So here the PCL is 0x02. So the program is currently at here, the go to 0x1. So it is 0x2. So yes, that's the value. So here is the full view of the program, and you can run it and then pause to see what is the value of the W register at the SFR. So that's all for today. So I hope that I answered the question. So after the W register approach 255, it resets back to 0. So thank you very much.